start. Okay, today we're going to be covering some like physical evidence. So, kind of an overview. So today we're going to be doing hairs and fibers. So, any of this stuff could be left at a crime scene, like if something falls off of my head, and that could be something super, like you could identify me from my hair. Or like it might be like a plant or an animal hair, and like different kinds of animals, like maybe your pet hair is like fallen to the crime scene, and then we could like use that to identify you. So that's basically what we're going to be covering today. And we're going to be talking a lot about like microscope images and how to identify different like hairs and fibers using those. And yeah, have you guys used microscopes before? Like maybe in class or like outside of class? They're super cool. They let you use them. Yeah, so if you get a chance, didn't let us use it in 6th grade. I feel like in 6th grade maybe we used them, but you'll definitely get to use them more as like you get older, I think. Definitely. And like if you ever get a chance to go to like an actual lab, they have a ton of microscopes, and it's like super cool. So you can look at a ton of different things. And yeah, so we can talk about some of that today. Okay, so here's like an intro about on like a hair, the structure of a hair. So like you look at your hair, like this thin little strand, and it actually has like many different layers to it. And if you look at it up close, like the outside of it is actually not super smooth. So the outside is called the cuticle, and it is actually composed of scales. So that's why like when you run your finger along your hair one way, it's like feels more smooth, and if you run it the other way, it feels like really like rough, and like you can't, it's like harder to like move your hand that way. So it's actually made of scales. And then the second to most inner layer is called the cortex, and that is like where the protein part of your hair is, and that's like what makes up the most of your hair. And then the center is called the medulla, and that's like the core inside of your hair. And sometimes it's like not even there, especially in a lot of human hair, it'll be missing. And that's like one way you could identify it. And when you look at hair under a microscope, like a really strong microscope, your hair will like, it'll become like this thick, and you can actually see each individual layer. So a cool way to, you could think about this is like, it's like a pencil. So the, like a yellow pencil that you use for like standardized testing and stuff. Let me see if I can get one. Okay, so like a pencil, like this one. So like the cuticle would be like the outside yellow paint. And then next on the inside would be the cortex, which is like the wooden part. And then on the very inside is the medulla, which is like the lead part of your pencil. And that's just kind of like an analogy of how you would like identify or like think of these parts and like remember it. So it goes cuticle, cortex, medulla. And we're going to be talking a lot about the medulla because it's like really important in identifying like different like species, I guess, of like animals and how to identify their hair. Okay. Okay, so first we're going to be talking about the cuticle. So the cuticle is the outermost layer of your hair. And this is like a more zoomed in look. So that's what I'm talking about when it like could be a little scaly, and it's like flaky and stuff. So that's what it looks like. There's many different thicknesses of it, and this is like where your hair is pigmented. So only the most outside layer of your hair is really colored. So like if you have like blonde hair or black hair, brown hair, whatever color you have, the pigment comes from the cuticle layer of your hair. And melatonin like determines the color. Yeah. And it is usually only different in species, not really in different individuals, except for like pigment. And yeah, it's definitely used to determine like cat hair and stuff, we use the cuticle a lot. So yeah. Next, the second layer is the cortex. And the cortex in this picture you can see is like the orangish part of the hair. So like the yellow would be the cuticle, this would be the cortex, and then the inside black stuff is the medulla. And this could also have different thicknesses, different textures, different colors, but it wouldn't like determine like the color of your hair. And then it also can help us determine the individual the hair came from, and that is using like the thickness of the cortex. Also, I think, okay, wait, never mind. And then finally the medulla, which could have different thicknesses. Like dog hair has a super thick medulla, and that's how we identify it. And then it could be broken or continuous. Like this one, you could see it's a broken medulla. And usually a lot of the times, human hair has a super broken medulla, and that's how we identify it. And then it could be opaque or like transparent-ish. And like you can see here, the black is super opaque, and that's like usually for human hair and dog hair. And sometimes it could be absent too, like the one in the middle, like there's no medulla there. Okay. Also, here's some like cool stuff I found. Like if you were at a crime scene and you see a hair that's naturally shed, like if you like see a hair, like you could look at the bottom of it and it definitely like looks like that. So this part is kind of like your scalp that like comes out of it, and it makes like a little bulb shape here, and that's like naturally shed. And then say someone is like chasing after you and goes and grabs your hair and pulls it out. That's kind of really aggressive, but like just say that happens, you're investigating a crime, right? So your hair could look like this, where like it's like bent at the top, or like it actually pulls out like more of your scalp, and it's like your skin. So yeah, that's just some cool imaging to know. And here's just some cool images of like how your hair is cut differently. So like if you use a razor to cut your hair, like say you're like shaving or something, and then the razor cuts it, it'll usually cut it at a diagonal, and it looks like that. And then split ends, like I don't know, if you have like longer hair, you like I used to love doing this and like finding split ends at the bottom of my hair, but this is what it looks like under a microscope, and you can see like how it like splits here, and then there's like darker areas where it's like weaker, and then a cut tip is just like cut straight across. And then age and sex is kind of hard to determine using hair, especially different like genders. It's very hard to determine because usually they're like roughly the same, except usually just like girls have longer hair, and yeah, but no stereotypes for us. Anyway, and usually when you're younger, your hair is more fine. Like babies have super fine hair. Like if you touch their hair, it's like little like wispy little hairs. And as you get older, it'll get like thicker. Yeah, and here's a link that I found, and there's more information on that. Exactly. Some girls have short hair, so we cannot like use really hair length to determine anything. And plus, like everyone has like shorter like hairs that are just growing out. So, you know, it's probably like hair is probably not the most useful things to determine sex. And here's a link that I found that you can find more information on it. It's like from the FBI, some like website, they're like archives, and I think it was super cool. Beards and mustaches. I'm pretty sure your beard and mustache hair is like the same as your head. Yeah, I don't think so. I'll have to look into that. Someone can Google it too, but I'm pretty sure it's the same. Like also like structure wise. Also, does anyone know like how you have to get DNA from hair? Like if I just like chop my hair off, like, and take the end of my hair, can I get DNA from that?
No, I don't know, but like I had a question. So why
Yes.
would you know how you cut your hair? Is it that important?
Um, Not really, but I guess like if it's like shaved and stuff, like
And maybe a
usually, yeah,
man one.
usually men shave their hair, so
Yeah.
that could like be helpful. But like obviously it's not like super like accurate or anything. It's just like
Okay.
speculation. Yeah.
And about the DNA thing,
Mhm.
I don't know. I think it's like actually grows. Don't know.
Does anyone else want to give it a shot? Where does the DNA in your hair come from? Like, because a lot of people are like, oh, like I'm gonna clone something, taking a strand of hair, but where does the DNA actually come from? I know we're not really talking about DNA this week, but does anyone have any
Like,
guesses?
you know, the ends of the hair, like where you pull it, like not the front where you pull it up, but like the ends, like
the
near the
small
head
things
scalp
like where
area.
it comes from.
Maybe you get like skin DNA from that.
Yeah, definitely. So, like, if we go back to the other slide, like this part of your hair where you like pull it right out of your head, there's gonna be some like skin cells on there, like Alan said, I think. Yeah. And that's where most of the DNA comes from because like your actual hair is made up of dead skin cells. So it's not really going to contain much DNA. So it'd be a lot more helpful if you had like the skin cells that are at the top of your head. So pretty cool. Okay. Now we're going to go over like 3 types of like hairs that are like pretty common. Like, I don't know how many of you have like a cat or a dog. Like maybe if they're dog hair, if they're you have a fish. I don't think fish have much hair, but yeah, if you had like cat hair or dog hair that stuck to your clothing and you went and committed a crime, maybe they could like trace it back to you. So cat hair is super scaly, like this. And it has these little like bulb thingies, but that's like just like showing how it's like scaly. Oh, birds. Birds, I'm not sure if feathers have the same have the same hairs as like if it's like has the same hair structure as like animals, but that'd be cool to know too. You have a sister. Your sister also has hair, I'm assuming. So it would be more like human hair. Okay. So it's super scaly. It has these bulb-looking things, and the outside is like scaly. Dog, thick medulla. So you see how the black part is super thick. That's what dog hair looks like. And then human hair is like this, broken medulla. You can't really see it super clearly in this, but like you can see how some areas are thinner and some areas are thicker. So that's, and sometimes human hair doesn't even have a medulla, so it just depends on the individual.
So I have a question.
Yes.
So when people have cancer, they have to do chemotherapy to get their hair out. But like, if the tumor isn't near the head, why do they need to take out the hair?
I don't think chemotherapy is like it doesn't have to do with their hair much, but it's like radiation. So they use like some like really high frequency of radio waves, and like radiation is not good for you. And yeah, so that's like nuclear power plants, that's why you don't want to go near them. But they use that radiation to kill off the cancer cells, and it also causes like yeah, like I think it causes like maybe your hair cells to die too. So it is definitely a side effect of chemo, but chemo, it's like affects your whole body, I think. So that's why even if it's like not near your head and stuff. Does that answer your question? Anyone else have any questions? Yeah, it makes you feel nauseous because like radiation, like I said, it's like if you if you don't need it, definitely don't go near it. Yeah. Okay. Any other questions on the stuff we talked about? Okay. Let's look at these ones. Okay. What do you think the first one is? Oh my God. Okay. You guys, oh, I accidentally clicked on it, but that is cat hair. You can see like the scaly ness of this with like the little things like that. Yeah. Okay. Does anyone have a guess for the second one? Is the cortex the thickest layer? I think it depends on the animal, but sometimes it is. I'll look more into that too. Yes, but yes, the second one is dog hair. Give me a second. I need to write down all these questions so I can look at them later. Yes, okay, dog hair. Last one. Oh no, you saw it already, but last one is human hair. See, you can see the super broken medulla, and it's like very segmented. And so next time, if you actually have a chance to look at a microscope and you have like a pet at home, it'd definitely be really cool to look at these different hairs and see how they're different under the microscope. And yeah. Okay. Cool. Next, we're going to talk about different fibers. So everything we talked about, the hairs, those are all animal fibers. So yes, we're all animals, but yeah, so we're going to talk about plants first. Do you guys know what plant this is? Probably heard of it before. It's in a lot of your clothing too. Okay, but
Cotton.
yes, that is cotton. So cotton is one example of your plant fiber. So if you zoom in super close at cotton under a microscope, it's going to look something like this. And one unique thing about plants is that the fibers are super twisted. Like you can see that like the fibers are like rotated around each other kind of. And that's like a super unique aspect to plant fibers. So some examples are cotton, hemp, and bamboo that you would use, like see in clothing typically. Bamboo is also seen in like a lot of like decoration appliances and stuff. And cotton does not dissolve in bleach. So that's why you can wash your clothes or like with bleach and it'll not just like disappear. And then when you burn it, it'll like be super ashy and smoke. Like, you know how you burn wood? Wood is a plant, obviously, and that will be burning. The fibers, these are all plant fibers. I'm not super sure what actual like plant it is, but it could be cotton or something else. I don't really know the difference, how you differentiate between different kinds of plants, but this is definitely a type of plant fiber. So yeah, like one way you could tell the difference between different different fibers is by how they burn. So if I take like a cotton shirt and I burn it, it's going to be super smoky and flamey, and it's going to like be like paper almost when you burn paper. Yeah. So have you guys ever used like Bunsen burners or something in a lab and like can burn fibers with them? And it's kind of cool. I don't know. So yeah, that's your plant fiber. Okay, next we have animal fiber. And this is like a more in-depth look at like what we talked about earlier with the hairs. So you have the medulla in the very inside, and then on the outside you have the cuticle scales, and then you can see the cortex. I guess if you look at it now, the cortex is like the thickest part, because this is like all the cortex, and the medulla is just like this inside very bit. But I'm not too sure which kind of animal hair this is, so maybe it's just that specific one because like we talked about, dogs have super thick medulla, so maybe the cortex is a little thinner for them. And animal hairs contain DNA, but not exactly their hair, I guess. But you can definitely get DNA from animal hair. Some examples are human hair and silk, which actually comes from silkworms. I feel like there's another word for them, but yeah, like I feel like a lot of people assume that it comes from plants, but silk is actually like an animal fiber, and like all the silk stuff you make, you like wear, I guess, like silk scarves and stuff. And when burned, animal hair is it smells like really bad. Basically, like burning, like if you burn meat, I guess, like if you're cooking and you accidentally burn it and it's like super charred, that's like the same thing that'll happen with animal hair. Yeah. Okay. And lastly, we're gonna talk about synthetic fibers. So synthetic is super like neat and organized. And this is not a good image, but I'll show you a better image later, I think. And they're usually used in clothing and carpets. So this would be something like nylon, maybe. So common used in clothing, nylon, polyester, spandex that you would use in clothing. And it's just like more efficient, I think. And there's like a lot of different properties of these synthetic fibers that are not in other like animal or plant fibers. So they could be made of natural or man-made materials, but they they are all man-made, and their fibers are twisted together like by humans instead of like by like nature, I guess. And when you burn a synthetic fiber, it'll smell very plasticky and have like a burning plastic scent if you ever smelled that. And there'll also be like a little like black, it'll turn into black goop basically. So after you burn it, it'll leave a residue, and that residue will usually be black and like a tar and super sticky. Not that you want to touch burned material, but yeah. And this is usually what synthetic looks like. You can see like these tubes are all super like the same. That's not going to really happen in any animal or plant fibers. And so yeah, that's how it looks. Okay. Anyone have any questions about plant, animal, synthetic? Okay, let's move on. Okay, let's see. What do you guys think the first one is? Any guesses? I'll give you a hint that these three are all the three that we talked about. So maybe process of elimination. How about we go to the last one first? This last one. This one might be easier, but what do we think the last one is? You have plant, animal, and synthetic fibers. Any guesses? You have three choices. So you have a 1/3 chance of being right. This last one right here. They're super neat and orderly, and it like crosses very organized lines. Synthetic. Yes, that is synthetic. So I don't really have another picture to show you, but this is what synthetic fibers look like under a microscope. And there's they're man-made, so we can control like how they look. So they'll usually like cross in super organized grid patterns. Okay, I feel like this one is the next easiest, but look at these fibers. Like, how would you describe them? They twist around each other. Do you guys remember which one was twisting? Plant. Yes, that one is plant. So you can kind of see how this looks like have you guys seen twine? It's kind of like twisted around each other, but that's like what plant fibers look like under a microscope, where it makes almost like a helix structure like DNA. So that's kind of cool. Yeah, and then the last one would be animal, and you can see like you can kind of see the different like layers of this, and it just like doesn't fit as well. So like process of elimination here: animal, plant, and synthetic. Does anyone have any questions about these? I would say this is more probably like human. I don't know, but like you can't really identify much from it because it's like more far away. But if you like could zoom in more, it'd be more easy to identify. But I don't know. We could pull up a picture, and there's also like you could see like rat hairs and like wolf and deer, and they all look super different. So yeah. Okay, let's do a cool little practice thing. So Nathaniel is wearing his new waterproof raincoat that he got for Black Friday, even though Black Friday is next week, but we'll just pretend it was this week. What might the fibers look like under the microscope? Which one do you think would be the most likely look? Let me know. You can message me or okay, yes, for sure they're synthetic. But which one do you think is more synthetic? Okay, a lot of people are saying C. I got some A's also. What do we think? I'll give you guys like a minute if anyone else wants to input. Okay, so the answer is actually A. Okay, so we all know it's not B. B is more twisted. That's probably a plant fiber. But raincoats, waterproof, you're probably using like polyester, nylon, something like that. So it's going to be a polyester, a synthetic fiber. And so A, it like crosses under each other in like a crisscross pattern, which usually only happens in synthetic fibers. And C would be more of an animal fiber because you can kind of see like the inside. There's like something there, maybe like a medulla that you could see, or I don't know, but that's like an animal fiber looking one. And this is what you're gonna see when you see more polyester fibers. It'd be a lot cooler if we could actually like look at these things under a microscope, but I just pulled these pictures off the internet. So yeah, does anyone have any questions?